All right. Hello, everybody. Good morning. Welcome back. Today we are starting chapter 4 of Vakil. Um, I'm gonna have my camera off because I'm traveling today, so I'm like, it's just kind of scuffed. Um, but yeah, starting chapter 4, big deal. So, so far we've talked about the underlying structure of the set of spec, the topology on spec. And these two things were really the set and the topology of an affine scheme. But the thing we were missing was the structure sheaf, which is O spec A, which we can think of for now as the sheaf of algebraic functions. And just from our Hartshorne knowledge, we can also kind of call these regular functions. Um, yeah. So these functions will have values at points, but won't be determined by their values at points. But, like all sections of sheaves, they will be determined by their germs. So, we want now to give a ring of functions on any open set, but we know that it suffices to describe the functions on a base of the topology. We will see that the base of distinguished open sets will make things much more tractable than you might fear. So we now describe the structure sheaf as a sheaf of rings on the base of distinguished open sets, which are like do not vanish sets. Um, and so O spec A df not equals 0 um, is the localization of A at a multiplicative set of functions which do not vanish outside of V of F. Um, this depends only on D of F and not F itself. Um, for example, like O spec A empty set is exactly 0. Okay, so this next thing he has as he's called a great exercise, um, which is just too funny. So AF to O spec A df is a natural isomorphism. Um, and so recalling that AF is everywhere where F doesn't vanish, localized localization um, everywhere that F doesn't vanish. And then that is exactly O spec ADF. Um, Like, I'm not bugging when I say that they are just the same thing, right?
That sounds about right.
Like, I'm looking back a little bit. Yeah. Okay. As a remark, if d of f prime is contained in d of f, or equivalently, v of f prime contains v of f. Define the restriction map. Res df to df prime from O spec A df to O spec A df prime. And so clearly this gives us a pre-sheaf on the base of distinguished sets. So um, so theorem this also gives a sheaf on the distinguished base and hence a sheaf on spec A. And we will call it the structure sheaf. Typically, this is notated as just O spec A. Or sometimes O if the context is clear. I just need to blow my nose real fast.
Yeah.
Okay. So the notation spec A will hereafter denote the data of a topological space with a structure sheaf. Such a topological space with a structure sheaf will be called an affine scheme. So equals affine scheme equals set topology structure sheaf. We continue to use the language of ring spaces, functions on open sets, global functions. An important lesson of this previous theorem is not just that it's a sheaf, but also that the distinguished base provides a good way of working with the scheme. Notice also that we have justified interpreting elements of A as functions on spec A.
Tim, it's set topology, or what's the last one?
Structure sheaf. Although I'll just write that as O. Yeah. I just need to blow my nose again. I'm sorry. This house is
No
a
problem.
dog that I'm very allergic to. Okay.
You're allergic to that dog, Tim?
Quite badly, yeah.
I would have never guessed.
Let's see. Okay, so to show that this actually does form a sheaf, so proof is a sheaf. We want to show first base identity, and then base gluability. So let spec A be the union of I and I of D of Fi, or the ideal generated um, yeah. Um, checking identity to make sure that it's 21. We know that there exists a finite subset of I 1 to n such that spec A is the union I and I, or no, I equals 1 to n of distinguished sets. Then let S in A, such that the restriction map of spec A to DFI of S is equal to 0 in AFI for all I, then we want to show that S equals 0. And then since this thing holds in A look less than Fi, there is some M such that for each I in 1 to n, Fi to the mth power equals, or Fi to the mth power composed with S equals 0. Now, F1M or FMM, that's meant to be an ideal, is equal to A is equal to the union of D Fi equal to the union of D Fi to the M. So there are Ri in A with the sum I equals 1 to n of Ri Fi to the M equal to 1 in A. This was the part of that thing that we didn't really fully understand. Which makes me feel like we should go back and do it. From which S equals the sum, because this is acting as 1, is equal to the sum of Ri Fim S, which is 0. So IG holds. And now to check gluability. So JP Serres described this as a partition of unity argument. And if you look at it in the right way, his insight is very enlightening. Suppose again that U, I, and I of dFi is equal to spec A. And suppose we are given elements in each KFI that agree on overlaps. A Fi Fj. And the picture for this is that it could look like Where this is like fx over keeping in mind that functions on the spectrum are just ring elements, and so I'm writing f of x rather facetiously here. Um, or wait a minute. Nope, this middle piece is not correct. Actually, I'm just gonna erase it for continuity. And then this is where it gets weird. Oh wait. I'm gonna have to make this all bigger. This is an important, like, picture, I promise. Okay. There we go. Okay. And so when we say agree on overlaps, what we mean is that this equation holds. So then let GI equal FI. We have elements. I didn't specify the elements. Um, FI to LI. Let's see. Then using DGI, we can say that so there exists M with GIJ or GI GJ to the MIJ. So does this make sense so far? I know I'm like not talking.
Yeah, it does.
Okay. Um, let bi be equal to ai gi to the m and hi equal gi to the m plus 1. So d of hi is equal to d of gi. Um, and I don't know if it's exactly clearly stated here, but the idea is that gi mod m 0. But then gi to the m plus 1 is congruent to gi. Um, then on each dhi there exists bi hi with overlap hi bj equals hj bi. Now the union over I of d of hi equals spec A implies that one A let R be equal to the sum of Ri bi's. This restricts to each bj over hj. So then our hj is equal to the sum over I of Ri bi hj. It's the sum over I of Ri hi. Did I write that right? Yeah, bi hj Ri hi bj is equal to 1.
Thank you.
Um, if our indexing set was infinite, basically, no, it wasn't. There's like a whole paragraph, but it just comes down to the one lemma about being able to restrict the DFI index to a finite set. And so yeah, basic ability is done, and so spec A in the structure sheaf on spec A gives a sheaf. Um, so as a remark, one way to, wow, that was not a Y or a W. One way to think about O spec A over any open subset U is the localization of A at the set of all functions who do not vanish on U. And so this was the characterization Hartshorne gave, right, as the ring of regular functions on U, because that is literally just the regular functions on an open subset are functions which don't vanish anywhere in the subset and are rational. And so this is kind of the most intuitive, I think. Um, Wait, hold on. Wait, is not.
No, it's not. I think, yeah, that next sentence kind of,
Damn, okay. That's embarrassing. Um, and as an example, if spec A is at 0, and let U be complement of the origins, then the function which is 1 on the first copy and 0. Hmm. Um, I'll admit I'm a little lost on why this disproves anything. Like the function,
yeah.
we're gonna pretend like we can draw a four-dimensional object. Um, so if that's the point of removal, then we're gonna characterize everything in here as being one thing, and everything out here as being part of the other. And so then it's constant and one here, but otherwise it's 0 here. I'm very confused. I don't think I get this.
Yeah, this is weird.
Um, let's move on for now and then come back to this.
All right.
Or maybe just think about it off off call. Um, okay. I don't know how to classify this. Remark Spec A modules from A modules. Um, let M be an A module. The following construction describes a sheaf M tilde on the distinguished base M tilde of df is localization of M at multiplicative set of functions not vanishing outside of V of F. Restriction maps work how they ought. Um, so then I'm going to claim um, um, I'm not gonna lie, I don't know if I can work through this right now. I think we should come back to this tomorrow.
Okay.
Um, just I don't know if I'm gonna be able to do this well. So let's go ahead and stop here.
All right.
And yeah, have a wonderful day. And
Yeah.
yeah, tomorrow we'll talk about OSpec A modules.
All right.
Cool. Let me turn off the recording.